Hello world, Ifecodes here. In this video, we are going to make an interesting web design, an interesting front-end design using Three.js. So Three.js is a framework that can be used or that is used to create interactive 3D web designs or 3D web pages. So as you can see on your screen, it's just a simple image of a car or an F1 car and that is running. Okay, as you can see, the road is also getting animated. The wheels are also turning real fast. Now, if I let me refresh it so that, all right, it will first of all show this loading screen. Once it has completely loaded, then the car will be, the car will appear. Then the overlay will disappear. Okay, this is a very simple thing to do, but it is not that simple. Okay, it is easy to understand the process, but it can be quite tedious. But thanks to Mr. Dube and Bruno Simon for making it possible for us to do it using Three.js. If not, if we had used what's it called, WebGL, that would be a pain in the behind. All right. So before we get to this extent, there are several things we have to do. So let us start immediately. All right. So first of all, in the description, we have to download some files anyway. So the very first one you have to download is the file that we needed in creating this, for example, creating Three.js itself. But we are not going to be using the normal style that we use, how to, let's say, load scripts using CDN, or we are going to be using npm so that we'll be able to install these packages and their dependencies. So I'll have to quit talking. Let me show you what I mean. So here are the files. In fact, here is the file or the folder that you need to download. So in this folder the person that prepared all of these files is Bruno Simon, first of all, or Bruno Simon. So he has already prepared everything. So all I did was just, tailor it to our needs, especially as this project is concerned. So once I will provide the link to this folder or this file in the description. So all you have to do is just download it. Okay. Once you've downloaded it, it is a Three.js project file. So I should have named it files, but anyway, no problem. So once you have it, there are also other things you need to download too. Make sure you have Node.js in your computer. You have downloaded and installed Node.js. If not, just head over to their website and get that Node.js. Simple. Then after downloading Node.js, you also need to download what's it called? You also need to download any. Well, this one is optional anyway. You need to download, or you have to download what's it called? A command line app. Okay. For example, what I have here is Git Bash. Okay. Git Bash. Once if you download Git Bash from their website, of course, you then be able to have access to it here. So all you have to do is you go into the folder or this directory here where you see src static and package.json. So all you have to do is to right click. And then once you right click, you see open Git Bash here. Okay. So let me do it immediately. Okay. Now I have it. So let me see now if I have, for you to make sure that you have what's it called, Node.js installed. So you simply type here node-v. Okay. Once this is the version of the Node.js I have in my PC, in my computer. All right. Also, we'll be needing npm, but don't worry about npm because as soon as you download and install Node.js, npm comes bundled with it. So let me just type npm-v. So this is the version of npm I have. So npm is what I'll be using to download the Three.js framework into my project. Okay. If you don't have Git Bash, you can always download something like PowerShell. Okay. Or another thing you can do is you simply hold shift, then right click. You see here that is you see open PowerShell window here. I think you will see open command line or something like that here. So they are all the same thing. So once everything is set, we now have to proceed to download or to install the packages that we'll be needing to run our what's it called correctly. So first of all, inside this you get this index.html, then script.js, style.css. Then static is where you get the models or the model, please, that we'll be using. That's the model of the car that you saw in the intro or in the demo of the project. Then you also have the textures, okay, the environment maps, okay, the cube maps. All of these things come inside that the threejs project file that you need to download. So once you have that, and this one is set, simply type npm install. This is to install threejs, okay? So simply type enter. So I'll have to allow it to run. Okay, all right. As you can see, it is installing. Just look at this place where the mouse is. We see node modules. Okay, node modules. That is everything that we'll be needing in this project. Okay, let's allow it to install. All right, now we are done. Okay, so let me see what is inside the node modules. You go down here, you see 3. So as you can see, it says threejs. So this is inside. You see animation, audio, cameras, core, extras, geometries, math, objects, renderers. All these things, we encounter them as the projects, as the tutorial progresses. Okay, so now after all of these things, we are not yet done anyway. What we have to do now is to simply come over here and type npm run dev or run dev. Enter. That's all. All right. So here we have our what's it called? Our app running on this server. All right. So let's start immediately. So here we are. Everything has been done. Anyway, much of the setup has been done already. So let's see if our web page is actually connected. I mean, our files are connected correctly. So simply type hello world. So I save. Now I go straight to the browser. Let me see what I have there. Yes, hello world. Cool. So let me quickly remove this. So I save, go straight. Anyway, as you can see, the script is already, everything is already prepared. So just head straight to the Java, sorry, script.js. All right. Now the first thing we have to do is to import threejs. So say import asterisk or star as 3 from 3. So we are importing everything from the threejs folder that I showed you earlier. Okay, once that is done, just save. Let's move on. Then the next one is to handle the canvas. Okay, the canvas is where everything happens, where the drawings, everything, the models, the whatever, the displays happen. Okay, so we grab it from here, canvas. Okay, with the class name of WebGL. So that is what we are going to do. So simply say canvas canvas is document.querySelector WebGL. Okay, so let's see if it's actually connected. All right. So we'll check that by saying console.log canvas. Let me save it. Go straight to the browser. Now I inspect canvas. So it is well connected. All right, so let's continue. Now let's take this one off. So the next item we are going to do is the scene. We have to create the scene. Okay. The scene, that is SCENE, is like a in threejs is like a virtual container. A virtual container that holds everything you want to see or render, objects like, or things like objects, the models and other things, the characters, the lights, the cameras. For example, in GTA, the cars, the let's say CJ or Michael or what's the other guy's name, the crazy guy, the crazy white guy, Trevor, or any of them, all those people, the NPCs, all those things are inside the scene. Okay, so the first thing we have to do is to create the scene. So here it is. Okay, so say const scene is new 3 dots scene. All right, so the next one we have to do now is handle the camera, because without the camera we'll not be able to see anything. All right, now we have const camera is new 3 dot perspective camera. Anyway, in case you don't understand what is going on, as you can see, we say new 3. 3 is capital. Okay, make sure it is done with capital. Don't do it with small letter, because it's not going to work. This is an object. Okay, so say new 3 dot scene, and even the scene must be the S must be capital. It must be capitalized. Then the perspective camera, the P must be in capitals. So what is perspective camera? Perspective camera is simply, for example, when you are playing your GTA, you see that the houses, the buildings, the cars that are far off, or objects that are far away, appear smaller than the objects that are nearer to you. Okay, so that is the perspective camera. The other camera we have in Three.js is the orthographic camera. That one is more like when you're playing RTS games. For example, what games can I say? I'm not really into RTS games, real times strategy games. But I believe, like, once I played very a long time ago. I think Dune. Okay, well, that's an old game. No, RTS games, I've forgotten. I can't remember. I think Worldcraft or something. Anyway, let's continue. Now, the perspective camera expects some what's it called? Some arguments or some parameters. But here they are. I won't go into it too deeply into what what is all of these things do. You can search that on your own. Now, the one I want to focus on is this number here called 75. Okay, this is the focal point. So the focal point is, it is important because we are going to tweak it later in the project. Okay, so if you don't know what focal point is, you can Google it. Then the next one is sizes.width, sizes.height. So unfortunately, we haven't created this one. If we save this now, to give us an error. So because we don't know we haven't given the scripts or the app, or we haven't told JavaScript where the sizes come from. So we have to handle them immediately. All right, let me save first. Now we are going to deal with the sizes right away. So what we'll do is we go up here, we go down, press enter several times. All right. So we'll say const sizes is, this time around we are going to get an object. Okay, as you can see here, sizes.width, sizes.height. So we'll create the object here. So in the sizes, we have width, we have two objects or two items inside the sizes object. So we have the width, we have the height. So the width is corresponds to the window dot inner height, while the height is window dot inner width is for the width. Then the height is window dot inner height. So if you know a thing or two about in JavaScript or in CSS, I think you should already know what inner width and inner height are. If you don't know, simply this is from here, as you can see the mouse here, from this place to this place, this is the inner height. Then from here to here, this is the inner width. Okay, so this is for the sizes. All right, so let me save and make sure that we don't have any error. All right, inspect. All right, there is no error. So let's continue immediately. Now the next thing we are going to handle is the rendering. All right, so the rendering means to render means to draw whatever on the screen. So that's what we are going to handle next, and let's do it right away. So here we have const renderer is new 3.WebGL renderer. Okay, this is a method. So this method as as a parameter, it expects an object. Okay, so what are the objects that we need here? We'll need to get canvas. Okay, the canvas will be canvas. So we are getting the canvas. This is where we are going to render whatever we are rendering. Then the next one we are going to do is called anti-alias. Okay, anti-alias. So anti-alias will be true. So what anti-alias does is to turn on, the anti-aliasing, which makes the 3D scene to look cleaner and more polished, so that our graphics don't end up looking like that of PS1 graphics. Okay, so we are done with this. We're done with renderer, but not exactly done. Okay, there's some other thing, or there's one thing that is left to be done. So let me save it first of all. I head over to a browser. There is nothing. Okay, I refresh. There is nothing. So there is something that I still have to do. So let's do it right away. So what I have to do now is to go down here and say renderer dot render. Render means to draw. Okay, to draw on the screen. Renderer dot render. Now what are we going to? We can't just render anything. We can't just have it like this. So it needs parameters. Okay, as usual. So the parameters are scene. Okay, then the other one is camera. So, oh, sorry, please. Camera. So renderer dot render camera. Now let's see what we have. I save. Head over to, now we have this black square. All right. Okay, but there is something I haven't done. Okay, because as it is right now, if you load any models, we are not going to see anything. So because the camera, we are not yet done with the camera. So in Three.js, whenever you create anything, any object, any new object, you have to add it. You have to specifically add it to the scene. Okay. So what we have to do now is, to say, sorry, scene dot add. Then what are we adding? We're going to add the camera. Okay. Then another thing we have to do now is to position the camera too. So we'll say camera dot position. Then it expects 3 parameters. The parameters X, Y, and Z, or Z if you are in the United States of America. So that corresponds to the position of the camera on the scene or on the screen. So let's start by using 0. So 0, 0, 0, the triple zeros mean, yeah, we are going to position the camera exactly at the center of the scene or the screen. So let me save, make sure that nothing is wrong. I save, Control S. Now I go to the browser. So it says, okay, camera.position is not a function. Oh, wait, let me correct that mistake right away. Yes, it is camera.position.sets. Okay. Now let me save. Okay, it's gone. Now, as you can see, it is only occupying just a little space up here. Okay. But we want to make it to occupy the whole screen and to also make it responsive. All right, so we're going to do the resize and full screen section right now. So the first thing we are going to do about the resizing of full screen is to, okay, handle the full screen first. Okay, so you come over here in the renderer section. Okay, so whatever we are going to do now must be done above renderer dot render, because this one is the last thing we are going to ask the renderer to do. So we should, at least by the time we get to the rendering of it, we have done, given all the parameters that we need to add. So we simply come over here, enter, then you say renderer dot set size. Okay, so now we're talking about full screen. Okay, so set size. Then where are we getting the sizes from? We're getting it from here the sizes dot width and sizes dot height. So simply say sizes dot width. Okay, then the other one is sizes dot height. All right, now let's see if it's working. I save, go straight to the browser. All right, you see it's now occupying the whole real estate. Okay, so there is one more thing also that we have to handle. So it is called the set pixel ratio. So the pixel ratio is, to take into account the type of screen the user has. So if the user has a screen that has more pixels packed into it, so it has to also use it to the full, or at least to the full, so that the images that will appear will not become blurry. Instead, it will be sharp. Okay, so let's do that right away. So in order to do that, we say renderer.setPixelRatio, then window.device pixel ratio. So here it is device pixel ratio, the how many pixels that are packed into your screen, into the screen of your device, be it your mobile phone or your computer or your TV. So we then round everything. Then this tool is simply to cap it to make sure it doesn't, if, for example, if it is a screen that is really, really powerful, we don't need all of them. So we have to cap it to 2. Okay. So you can always go to Google and search for all of these things. So we have to move on immediately. Now let me save it first of all. The whole thing is black. Okay. So what we have to do now is to load what is called, to change the background, because the background right now is just dark empty space. So we have to change the background into something, like a sky. But before we do that, we have to first of all do something that is called CubeTextureLoader, because those textures are the texture that we'll be using to create the sky. Okay. All right, so the first, what we have to do now is to go to the uppermost part of the whole thing under this import statement. All right, so let me just say loaders. Okay, loaders. So now, because we are going to load other things, for example, we are going to load the model. So now we are going to create const cube texture loader. Okay, so it's new 3.cube texture loader. So what's this all about? In in a let's say in a video game, for example, there's something called skybox. So the skybox is a big cube, hence the cube texture loader. So it's a big cube that is surrounding your 3D scene, okay, with a sort of sky-like image on the inside. So it looks like you are inside a world. For example, a world occupied populated by something like mountains, space, mountains. I've already mentioned mountains, sky, buildings, and so forth and so on. So a skybox is made using 6 images, one for each side of a cube. These images, they are stitched. We're going to stitch the images around your scene to to simulate a distant environment. And again, it doesn't move with the camera, okay? So because of that, it appears or feels far away, okay? So now we have gotten this cube texture loader. We have to load the textures that we will need. I showed you the texture, or I showed us the texture in the intro. Okay, so let's move on with that right now. So let's do it. So go to the canvas, below the canvas section. The images we are going to load are called environment maps. So let me type it immediately. All right, so say const. So const environment map is the cube texture loader dot load. Now we are going to provide an array of the item inside this method. We are going to provide an array of images that will be used to create the environment map. So where are we getting them from? I showed us earlier where it is coming from. So you go to the static, then textures, then environment maps, cube map. You see, so you see NX, NY, NZ, PX. So N is negative, P is positive. So positive X, positive Y, or negative Y, sorry, negative Z, or negative Z, positive X, and so forth and so on. So let's save time. So what are we doing here? Please pay attention, okay? So what I'm going to do now is what's it called? This quotes, okay? It is a string. Now we give it a front slash, then say textures. Okay, where is this textures? So is this folder here? You see that for this folder here. So we are inside the textures. Then inside the textures we have the environment maps. Okay, then inside the environment maps we have a cube map. As inside I'll have this. So don't be surprised if you see something. It is exactly the same way in your system, in your computer. Okay, so don't worry. I just want to save time. All right, let's continue. All right, here they are. Okay, so we have loaded everything. Loading all of these is not enough, so we still have to commit something somewhere. But let me save anyway. I save, then I go straight to the browser. It's still dark. There is nothing. Okay, it's just a dark world. So what we have to do now is to commit it. So we'll say, you go down here and type scene. So say scene dot background. Scene dot background is environment map. Okay. Now let's save and see what we have. Okay, there's an error. It says cannot access scene before. All right. Okay. So let's correct that right away. So what happened is that I did this environment map on the wrong at the wrong place. So what I have to simply do is to cut out this scene. Okay, I cut it out, then move over under canvas, under the canvas section, and paste it there. So let's see what we have. Still have an error. Oh, all right, I remember. It is not an error. Okay, it is not an error. Because calm down, relax. Okay. Oh my God. Anyway, please. It is because I'm trying to be faster than my own legs. Okay. I skipped one one step. Okay, so let me go back and do that step, please. Let's do it immediately. Okay, it has to do with the rendering. Something anyway. Let's just do it. Enough talk already. So the reason why it didn't work is that in fact, it's not really an error. Okay, as I said earlier, it is because for any image to appear, there has to be an animation. Okay, it's not just a start because threejs is not just static. It's not just one. It's not just static. It has to be constantly being animated. In fact, you have things like frame rates. Okay, because we are talking about 3D stuff here. So frame rates matters. Okay, so we are going to use something called request animation frame. Okay, so let's do it immediately. Let's deal with it immediately. So go down here and create a function, a constant. Why am I always making this silly error? Say we call it tick. So tick, we're talking. Of course, we're talking about frame rate. For example, 30 FPS means frames per second. So once you hear per second, so it means clock or time. So tick tock, ticking of a clock. So we call it a tick. Then we have to make this function. Excuse me. So what is it all about? What is this tick function all about? It is inside this tick function we are going to be calling the the request animation frame. So say window dot request animation frame. So let's see. So request animation frame method tells the browser that you wish to perform an animation and request that the browser call a specified function to update an animation before the next repaint, aka the next render or the next redraw. So request animation frame. So what request animation frame? So you have to give it a function that you to call. So the function that you to call is tick function. So all it's simply doing is just keep going round, 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 round. Okay, that's all. Just keeps on going round, 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 round. But we also need to run some other functions too. So that is when we take this renderer dot render, cut it out, then put it here. Okay, so we have to be rendering, we have to be redrawing the scene at each frame. But now this function would do anything, so we have to call the tick function first. Tick. So let me save right away. I save. Now let's go straight to the browser. All right, as you can see, okay, everything, we are now seeing something. But unfortunately, it is unresponsive. I did talk about responsiveness earlier, but I skipped it. So we have to go back to it right now. Okay. It's not really required, but please, let's just do it. I'll simply paste the code and explain. All right. So don't be angry with me. It's not really hard. What we are going to do now, we've done it before. So we are just going to handle the responsiveness part. There's really nothing to it. All right, so what we do now is to go under the sizes, because here is the resizing. Resize. Okay, so what's it called, the responsiveness. Okay, so we simply say window dot add, because resizing is actually an event, so we are going to be listening for an event called resize. So resize. Once there is this resizing, we are going to run the next function. We're going to run the next function. All right. So let me paste them immediately. So once there is a resizing, we'll have to take into account the new size, or yes, the new size of the window now. So we are going to update the sizes.width will now be this. Anyway, let me demonstrate what I mean. Inspect. Okay, now the size is no longer the same. Okay, if I go here and put responsive, you see this is resizing. Okay, so as I'm doing it now, it is updating the sizes of the window, the dimension, the width and the height. All right, so let's continue. So the next thing we are going to do is also to update the camera. All right, so let's do that right away. So we'll say camera.aspect, which is the aspect ratio. So the sizes.width over sizes, or divided by sizes over heights, dot heights. The width size divided by the height, okay, or the size with the height size. Then we also update the projection matrix. So this tells the camera to recalculate how it sees the 3D world, especially after you've changed settings. For example, a setting like field of view, it's at the aspect ratio or zoom. So without calling it, changes to the camera's projection settings will not take effect. Okay, so in real life, it's like after, pressing refresh on your camera after you've changed your camera's lens settings. Okay, so we have to take that. That's what this projection matrix does. Now we also have to update the renderer. Okay, so all we have to do is, or we've done this what we're about to do now, we've done it before. Okay, so the set size, we've done this one. Then the set pixel ratio, we've done it also. So I've already explained what this one is. So let me just save it and see what we have. All right, so you see how it is working now. You see, so now it is completely responsive, and as you can see, even here, you see these things are changing now while it wasn't changing before. You can rewind. Is it called rewind? I don't know. Rewind and I'm so old school and see if this one was working before. So anyway, so let's continue. Now we are done with setting the whole scene. Okay, we'll start adding objects into the scene now. The very first thing we have to do is to create something so that we'll be able, before I load the, what is it called, the model, I have to create something like just a little cube so that to demonstrate what we have in case you are new to Three.js. Anyway, before we do that cube stuff, there is something we have to do, okay? Because right now, if I forgot to do it, I forgot I tried to jump some steps, okay? So what is going on is that, as you can see now, we cannot pan around, we cannot dolly around, okay? We are just set in one direction. We can't really do anything with this. So we have to correct that immediately. So in fact, what I'm trying to do is use, to be able to control the camera, okay? To move the camera around. So in order to do that, we simply have to go up here. There is something called orbits, okay? Yeah, orbits. It's a fitting name because we want to be orbiting around, okay? So what we'll do now is say import. What are we going to import? We are going to import orbit controls. So orbit controls, okay? Let me copy something, okay? Because it's really long. All right, so orbit controls from where exactly is it coming from? So let's move back. So where is it? Node modules. You go to 3. But let me look for it where it is coming from, please. So here is where it's coming from. You go to examples, then you go to JSM. So this corresponds to what you're seeing inside here. 3 examples, JSM controls, orbit controls does JS. So controls. So where is it? Orbit controls dot JS. So these are other ones: arcball control, drag control, and so forth. But what we are interested in is in orbit controls. So orbit controls or JS. I mean, the orbit controls have been imported. So importing it is not enough. We also have to set some other things. So we go down to the camera section. Okay. Now what we have to do now is to say const come on, const controls. Then controls will be new orbit controls. Then we are going to add, because we are going to control something, we are going to control the canvas and the camera. So we'll first of all say camera, then the other one is canvas. Okay, so let's see if it's going to work. No, it's not working. There is something left we have to handle. So we come down again to the tick, or the tick function. Okay, first of all, let me do something here. Render, so that's to avoid confusion. Okay, let me go back up again and say up, no, controls. So what am I going to do here? I'll simply say controls dot updates. Okay, which is a function or a method. Now I save. Let's see if it will work. No, it's not working. There's something again. So it is actually working now. Okay, but remember I said earlier that this is just the skybox. So the skybox does not move with the camera. Okay, so that is why it's as if it is not working. So in order to make it, in order to see it in action, so I will just have to create a cube. Okay, let me create a simple cube. So let's do that right away. So here is the code for the cube. So first of all, we create a const called geometry. Okay, this is the geometry of the cube. So say new, we assign to it new 3 dot box geometry, because we are creating a cube. which is also a box. Then we have to give it the material. That's the color. Okay, we say 3.mesh basic material. Then the color is this green color. Then the cube itself is a combination of the geometry and the material. So we then put it inside this mesh. So everything combined together is called a mesh. Then the next thing we have to do is to add it to the scene. Okay, now let's check again if it is working. Nothing. Okay, don't despair. It is normal. The problem is that it's because of this camera dot position dot set. Okay, because I set it at exactly at the center. So the cube right now is kind of inside the camera. Okay, it's kind of inside the camera. So let me just kind of tweak it a little bit. So what I have to do now is the x for the x position. So let me just say 2, then the y position 1, then what is it called, the z position or the z position. Let's give 4. Let's see if it will work. Now I save. Okay, you see, if I hold the mouse, the left mouse, that is if I left click and hold it, so I can dolly around, I can also pan the model around. You see, so the camera is moving now. All right. So earlier I said I made a mistake saying that it doesn't move with the camera. Yes. Yeah. Anyway, what it means that it doesn't move with the camera is moving. Like kind of, let's say the camera is moving forward. Okay. The camera doesn't move forward. Now I'm zooming in. The camera moves forward, please, but the background doesn't move. But once the camera turns, the background also turns. Okay. But we are not here to see this fancy, beautiful green cube. So I think it's time to load the the model. Okay. So let's go over to the code and where is it? Take it off right now. This one. So I don't think we need it. So let's remove it, please. Okay. Now let me save, make sure it's no longer there. So the next thing, as I said earlier, we have to load the module. All right. But before we load the module, we have to first of all import what is called the GLTFLoader. Okay. So the GLTFLoader is GLTF is graphics library. I've forgotten what the TF means anyway, but this is the method or function that we will use to load or import, to bring in the model into our scene. So let's do the GLTF thing first of all. So here it is, say import GLTFLoader from 3 examples JSM loaders GLTFLoader.js. Okay, now we have this. The next thing we have to do is to come over to this loaders section and type const GLTFLoader, GLTF. Then GLTFLoader will be new GLTFLoader. Nice. So let me save. So now I have initialized the GLTFLoader. So I now have to load the model itself. So I go over to the under the scene.background line. Then what I have to do is say GLTF. First of all, let me. Okay. So I'll say GLTF loader. Dot load, LOAD. So we are going to load the model. Okay, GLTFLoader.load. So now we are going to provide the path to the model. Okay, so the path will be, of course, is a string, then /models. Okay, models /f1.glb. Anyway, don't be confused about GLB and GLTF. They are all the same thing. So the reason why I love using GLB is that everything is inside one file. rather than the normal GLTF where the mesh will be on one side, then the what's it called, the material, the textures will be on another file. So it's not that it is really hard to handle. It's the same exact same way, but I just like everything to be concise, you know, in one package. So now that we have given the path, we have to also give it this function. So say GL, inside this we have this, we call it GLTF. Okay, then again is a function, of course. So now what this function does is to, you know, the parameters of the models. Okay, so say anyway, let me just copy it, okay, because we're going to be wasting time if I type it. So say GLTF, right? GLTF dot scene, because it is inside the scene. Okay, GLTF dot scene, then dot scale dot set. So we are going to set the scale of the model. So we give it 10, 10, 10. So 10 on the x-axis, 10 on the y-axis, then 10 on the what's it called, z-axis. Then we also have gltf.position.set, gltf.scene.position.set. This is kind of a mouthful right now, okay, but we are going to handle that, you know, change it later so that it will become easier to handle. You know, like this, we don't have to type all of these things, but for now, let's just handle this, okay? Let's just do it this way. Then we also have the rotation, okay? So which is math.pi multiplied by 0. That's kind of half of math.pi, okay? Or half of pi, you know, pi, you know, the pi you're using, not the one you eat, the one you use in math. So at the end of the day, we then add the GLTF or the model to the scene. So we say scene.add GLTF.scene. So now let me see if everything is working correctly. Let me take this one off first, please. So let me see if it's working correctly. I save. So here is the model. Here is the model. But as you can see, it is really, really black and unfortunate. Okay. I'm not saying that black is unfortunate, please, but this is not what you want, okay? Don't get me wrong. All right. So the next thing we are going to do now is to do what is called updating materials. So it's because of materials, that is why, you know, the color is off. So we have to first of all update the materials. Materials, that is the color, if you paid attention in the cube section. So let's head over to the code and do it immediately. So we go to the scene section. Under the scene section, then here it says update all materials. So say const update all materials. All right, is or will be a function. So what we have to do now is to go around all the scene. Okay, we have to enter into the scene. We enter into the scene, then go around it, make sure we catch everything there. So in order to do that, we will say scene.traverse. Of course, you know what traverse means, so we have to enter into the scene. Okay, now we have to, every material or everything inside the scene will be excuse me please, everything inside this scene, both the camera, everything, the models, they are all children of the scene. Okay, just as in what is it called, in HTML, body, now you have the body, canvas is a child element of body, scripts is also a child whatever of the body. Okay, so everything inside the bodies are child or children elements of this body elements. All right, so that's exactly what we are doing here. So every item inside the scene is a child of this kind of child element of the scene. So we first of all provide this what is it called, variable called child. So each of those children or any of those items will be stored inside this child element automatically. So now what do we do once we get any child or any child element? So we say if child if is instance of a 3 dot mesh. Okay, what we are doing here is, if it's an instance of mesh, if it's a mesh kind of, for example, when we do that, when we did that cube, you can see where I wrote mesh. Let me go down. Where is that cube? Okay, it says 3.mesh, so the geometry and the material. So once you have this mesh, if it's an instance of mesh, which is, if for example this, let's say this tire now, or this wheel, this is a mesh. Okay, so if we get this, we have to update the material. All right, let me go back up. Where is it? Where is it? Where is it? Okay, instance of 3.mesh, and because we are not yet done, and child.material is instance. So first of all, what is standard material? Standard material or mesh standard material is kind of material that's tries to imitate real life objects. You know how they look. For example, if it is metallic, how they look. If it is robbery, I'm not mean robbery as in going to rob somebody. I mean, if it is a rubber, it has that rubbery look. If it is a glass, it will have that glassy look. Just as in GTA, the windshields or the windscreens of cars look like glass. The clothes look like clothes. The roads, asphalt and all that, they look like the real one. Okay, because we also have other materials. For example, basic material. That one is totally different. But anyway, if you want to know more, you can always use Google. Okay, Google is your friend in this case. So what happens is, if these two conditions are met, okay, so let me just paste it so to save time. So the child material, the child will become what am I even talking about? The child.cast shadow will be true. We also have to make it to receive shadow. So kind of in real life, once there is light shining on any object, it casts shadow on what it is standing on, or what is next to it, or what is near to that object. So we are going to cast shadow, and the objects should be able to cast shadow, and it should also be able to receive shadow of other objects around it. Okay, now let's save, make sure there is no error. All right, we are not yet done. Okay, there are still other things we have to do. There are some steps we still have to take before the car becomes like a real car. All right. So let's continue. So before then, please, I need to do something. Okay, because we should be able to. So for this thing to appear correctly, as in the real world, we should be able to, because to tweak some values. But the problem is that we are not going to be, for example, we come here, we change it, then save, come over here to see what it looks like. No, 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 that will not be proper. Okay, because we are going to set all these things. Requires a lot of tweaking, setting. Like when you want to set your camera to take a nice picture, it's not something you can just do, within a twinkle of. You at the snap of your fingers like this, then it's done. No, you have to do a lot of settings. You have to even reset. So basically, that's what we are going to do next. So we are going to import something called that.gui, or in our own case, that's lil-gui. Okay, it's just a small let's say a small dependency, or a small JS code that will help us to be able to do that. So let me show you what I mean of. In fact, let's start right away. We do not have much time again. So we go up here. So we'll say import as that from lil-gui. Okay. So in the past it used to be that.gui, but this new one is lil-gui. Okay. So we import everything as dat or that from lil-gui. All right. So as I said earlier, we are going to be using it to do some tweaking or debugging. All right. So what we have to do now is to go under CubeTextureLoader. Okay. So let's call it debug. So say const GUI. Of course, you know what GUI is, graphical user interface. Okay, so const GUI new darts dot GUI GUI. All right. So the next thing also we have to do is to say const. All right. Now with this, we'll be able to tweak our values directly from the page, from the page itself. So let me save. Okay, I go to the browser. Now we should be able to control whatever value you want to control directly from here. Instead of going over to the code editor, enter whatever value you want to enter, then we come over to the browser and then check how or what it looks like. No. We should be able to do it live. All right, so let's continue. Okay, what next? Okay, the next thing we are going to do is to do some lighting, to add light, because we are taking the environment. We also need lights from the environment, but we also have to put another light again. So this time around, we are going to put something like sunlight. Okay, let us not be tired. We are going to do the lighting right now because as it is dark now, I'm not happy about it. So let's move straight over here. So we go over to below the update all materials, then okay, yeah, lights. So in order to get the lights, the light we are going to use is called directional light. So say const directional light will be new, or there are other lights. Okay, you can use Google to check other lights, or like spotlights. It depends on, for example, in Blender there are, the 3D software, there are different lights depending on what you want to do. Okay, area lights and all that. So but this time around we are going to use directional lights because the scene we are trying to create is outside. Okay, so we are going to be receiving sunlight. So in order to in Three.js to kind of simulate sunlight, that is where we use directional light. So we'll say, sorry, new now we have to give it the color 6. Okay, which is white. All right, we are looking for white light. Then we are going to give the intensity. Okay, this is the intensity of the light. Fine. Now we have to add it to the scene. So we'll say scene dot add, then directional lights. Okay, so let's see what we have. All right, you see, this is no longer dark soul. All right, so let's continue, please. Yeah, before then, please, we want to be able to tweak where our lights, the position of our lights, the direction of our lights. Okay, because it will help in other things like casting of shadows and so forth and so on. So let's go straight in to do that. So here are the other parameters of the lights. So we say directional light dot cast shadow. You have to be able to cast shadow. Okay, then directional lights dot shadow dot camera dot far is 15. Then shadow dot map size dot set 1024 1024. I don't have to explain all of these things because I won't have the time to do them all. So at least we already know what these ones are. Then you already know what this position dot set is. Okay, so as for these ones, please, that will be assignment to go to Google and check what they are. Then the position, here is the position. So let me save it and see what we have. All right, okay, now looking so much better, but we can still make it better. So here we are going to do the tweaking, to be able to change the direction of the lights and the position. We should also be able to how do I put it, to change the intensity directly from here. All right, So we come down here, we say GUI dot add. So we are adding this to the GUI GUI. GUI is this one. So we want to add it here. All right. So GUI dot add. What we will first of all add the directional light. Then what are we trying to control? Intensity in this case. Okay, we start with intensity. Sorry, this is inside. It should be a string. So we are going to how do I put it? Control the intensity. All right. So now we are going to do the the steps. That's the maximum and the minimum. Okay. So let me get that immediately and paste it over here. So dots. So dot min. This is the minimum. Then dot max, which is the maximum. Then the steps is 0.001. Then the name of whatever we are trying to control or to tweak is light intensity. Okay. So we are trying to control the intensity of the light. So let's see what we have. I save, then go over here. You see, we now have these controls here, or these things here. So let me raise it in place. Okay, light intensity. You see, the more if I decrease it, it goes completely dark. Then if I increase it, you see the whole thing becomes a bit washed out. Okay. So you can control it to any value you want. That is entirely up to you. So we have other things to control too. Now let me just get all of them and paste because you already know how it is done. So let me just paste the rest. Fine. So this is the position, then X. Okay. Directional light dot position X. Be careful because the other time we didn't put position. I mean, we didn't put dot something. So we simply put the part with what we want to control or what we want to tweak. But this time around, we put the position because we can't just put X directly. So we first of all put this dot position before we type give it any let's say any parameter to control. Now the name is light X, then the other one is position Y, name is light Y. So we're trying to control the positions of the light. So let me save. I go over to the browser. Okay. All right. So let me take this one up. Okay. Here is intensity. Then you see it is moving. The light is moving. When I tweak whatever, what's it called? The X axis. Then what about the Y axis? I think the Y axis is going up and down. Okay. Then the Z axis is coming towards me or moving away from me. All right. So we are done with the light. So the next thing we are going to do is the environment map intensity. So what it's all about is that, as you can see, we are getting light from the background, from the scene in the background from the background, whatever, the sky, for example. We are also able to get light from there so that we make everything look real, because as it is now, it looks a bit more like I don't know, 3D cartoons or something. So it doesn't look real. So the next thing we have to do now is to do that environment map intensity, so that let's see what it will look like anyway. So let's move ahead immediately. So we'll go up. Where is it? Okay. No, not there, please. So we come over here. Where is it? Okay, over here. All right. So in order to do any tweaking here, we first of all remember up here we did a debug object. Okay, this object here. So we are going to work with it right now. So say debug debug object dots environment map intensity. So will be let's start with 2.5. Okay, then we are going to do we are going to add it to the GUI. All right, so what we have to do now is say GUI dot add. Okay, we are adding the debug object, debug. So the debug object, then the environmental map is environmental map intensity. So say env map intensity, then uh, excuse me, so I just want to make things fast. So all I have to do is just come over here, then copy sorry, copy from here. Okay, copy. So I just paste it over here. So remove this. So minimum is 0, maximum is 10, step 0.001. Then we say dot on change. So whenever there is any change on change, that is whenever we come over here and change stuff here. So on change, we then run this update all materials function. Okay, so copy this one. Here is it. And on change, we'll all right. Dot on change, we run all the updates all materials method or function. Now let me save and see what is going to happen. There's an error, so let's check because I know where it is leading me to. All right, said uncut type error. On change is not a function. Or all right, so like here it is. Right now it's not going to work because there are certain things we have not. This is light intensity. Okay, so this is environmental map intensity. So the environmental map intensity is just the light coming from the environment, so it's still going to affect our objects or the car itself, the F1 car. So there are other things we have to do that we haven't done. So let's continue and do them immediately. So the next thing we have to do now is to go back to renderer. Okay, the renderer section. Okay, it's not just these two things. There are other things, to make it look much better. Okay, there is something called enable physically correct lights. So we'll say renderer dot enable please, it's not enable, so say physically correct lights true. So let's see what we have. You see it has changed. It has changed. So it looks, when we increase the intensity of the light, it looks a little bit better. So what we are doing now is just to try to make it look like real, as if it was taken with a camera. So that's what we are doing. So let's continue. So here are other things, other settings that we need to put inside the renderer. So the renderer.output encoding is 3.sRGB encoding. So sRGB is just color encoding to make sure that every color appears just like it appears in the real color. So remember, RGB means red, green, blue. Okay, so as if you're just watching TV. All right, just take it like that. So that's kind of color correction. Okay, now the tone mapping is 3.Reinhard tone mapping. So tone mapping is just kind of how we want the appearance to be. Okay, so we have different, we'll talk about those different types of tone mappings we have. So this is basically the appearance, whether it's going to be bright, whether it's going to be very bright, shine, should I say shiny? In fact, at the end of it, just to make it look as if it is GTA 5 that you're, dealing with. Okay, so then this one is the exposure. Of course, when we talk about exposure, like in Photoshop, to make it very bright or very dim, Then the other one is the shadow. Okay, so let's see. This is not all, but let's just see what we have first. So the other one, this one, okay, yeah, shadow map enabled. So to be able to enable objects to be able to both cast and receive shadows. So what I mean by casting shadow is that casting shadows on objects around it. Then receiving shadow is other objects can cast shadow on the other objects. So, or should I say object A should be receiving shadow from object B as far as light is coming from a certain direction, just as is done in real life. So let's see what we have. All right. Now you see, it's now so much better. So much better. But unfortunately, you see that the background is kind of washed out a little bit. Okay, so much better. It looks more like a real life car. Okay, but we are not yet done. Okay, we are not yet done. There is one more thing left in this renderer section. So, sorry. So over here we have the renderer.shadowMap type 3.pcf soft shadow map. So what it does is that in Three.js, shadows look, it makes the shadows to look softer and more realistic instead of the hard sharp shadow edges. This one will create smoother blurred edges by blending nearby shadow samples. So think of it like softening the outline of a shadow so it looks more natural, like shadows in real life. Okay, it won't be looking like shadows in it will not be looking like shadows in what is it called, in PS1 games or Sega Saturn games. So this is what here is all about. Now let me make sure that there is no error. We are not going to see the effects of this one right away, so that will be in the next video. Okay, so you see even the textures are all clear. Now we still have a few other things to handle. Okay, so let's continue. So let's go back to the environment map. What we are doing now is to set the scene.environment. Okay, so say scene dot environment. This one will be environment map. So environment map. So what is the difference between scene.background and scene.environment? So scene.environment, we already know what scene.background does. So what exactly does this one do? The second one, that is the environment. What it does is that it makes objects in our 3JS scene look shiny by reflecting a surrounding image. For example, like let's say a sky or room on them. Okay, it's like placing the cube or placing a, let's say, a cube, a shiny cube in a real world setting where it picks up light, color from the environment, so making it look more realistic. So let me save it. Let's see what we have. All right, see, now looking so much better. All right, so as you can see here, it's affecting it. So light intensity. Okay, great. What happened just now? Excuse me, please. Just be patient. You see. But anyway, let's continue. We are not yet done. We are not yet done. There are just few things we have to do. So one more thing we have to do is to set the environment map encoding. Okay, let me do it first of all. Okay, I go under here. So environment map dots encoding. Environment map dots encoding will be three dots sRGB encoding. So what is this all about? I've talked about sRGB earlier. Now let me explain it better. So in Three.js, when you load an environment map, okay, for example, like now we are using it for lighting and reflections. the encoding tells threejs how to interpret the color data in that texture. Okay, if the encoding is wrong, then your scene may look maybe too dark or too bright or washed out, having unrealistic lighting and or reflections. Okay, so now let's see what it's going to do. Over there, allow it to come up. All right, now it's looking so much better. It's no longer looking as washed out as it used to be. Okay, and we now have shadows. Okay, even you see this object that is coming out now is also casting a shadow. All right. Okay, there's just one more thing left. One more thing. Okay, so we have to come over here, the renderer. Like here I said, this Reinhard tone mapping. So we are going to talk more about this tone mapping right now. So first of all, what is tone mapping? Tone mapping in very simple terms is it adjusts how bright and dark and the contrast of an image, to try to make it look more realistic. Well, the image or the scene, to try to make the image or the scene to look more realistic, like how your eyes adapt to different lights conditions or to different lightings. So it helps to prevent overly bright, washed out colors, like in scenes with strong lights or reflection. So it doesn't act like there is so much light that it's kind of being washed out everywhere, that kind of thing. Then it is, again, it is like tweaking a photo's brightness and contrast so that it will look more natural on your screen. In threejs, it controls how the renderer processes the lights and color to balance highlights and shadows. Okay, so especially for physically based rendering, BBR materials, just as BBR materials are just like these ones. Okay, so our HDR environments. What are HDR environment? This sky now is an HDR environment. Okay, so now what we are going to do now is to try to we are trying to give ourselves options in this tone mapping so that we can have different options, because we don't all this is not only Reinhard tone mapping we have, there are others. Okay, so what I will do now is to do the das.gui. So I will not type it, I will paste it here, but explain, you already know how it is done. All right, let's do that immediately. Did I say that.gui? No, gui dot gui dot add, to add it to the that dot to add it to the GUI. Okay, so we say GUI dot add, then renderer, then tone mapping. It is part of a renderer. Okay, so we are looking for the tone mapping. Then here are the options. It is encased inside these parentheses here. Okay, so these are kind of objects. Now, no is no tone mapping, so there's no tone mapping involved. Then the other one is linear, linear tone mapping. Reinhard, the one we're already using. Then we have this one called Cineon. So Cineon tone mapping, or AES Filmic. This one also is, I kind of like this one too. This one is good. Okay, this is one I normally use in Blender. Okay, so after this, we still have to do some other things. There's one more thing left, please. So the one more thing left for this video is GUI.add renderer tone mapping exposure. Okay, so here is the minimum, then the maximum, then the steps. Now I save, go straight to the browser, allow it to load. All right, so here it is now. Now I have the tone mapping. So let me select another tone mapping, Cineon. Wait, let me try it again. Okay, this is no tone mapping. All right. To me, it doesn't look that good. It looks like cartoon. Now let me choose ACES. Okay, Filmic. This one looks a little bit too washed out, but anyway, let me. Okay, we can control the exposure. Okay, all right. So it's entirely up to you. So Let me go back to Reinhard. So we are going to stop here. In the next video, in the next tutorial, we are going to do all the other remaining stuffs. So this one is already, it's already too long, please. And editing this video now, oh my God. Anyway, thank you so much for watching the video. Please like the video if you like. If you have any question, please endeavor to ask me in the description, in the comments. Like the video, share it to 10 people. This I ask you, please. I am on my knees. So thank you so much. Goodbye. See you next time.